So, welcome back. I hope you enjoyed your break. We will continue with the first afternoon sessions. Joining us now via Zoom is Mert Coskuner, and he will talk about application security in Agile environments. Please enjoy.
Hi everyone, welcome. I'll talk about application security programs in Agile environment and mostly at scale. How can you do that and stuff. And my agenda will be I will first introduce myself, and after that we will go over some definitions like application security and Agile practices, which I believe is still very controversial in terms of the definition wise. And after that I'll talk about the two approaches that I'm generally approaching when it comes to application security. So the one is the proactive approach and the other is the reactive. So proactive one is the what I would like to call the activities that security engineers are doing before deployment, before the developer deploys the application. So the reactive approaches would be the activities that security engineers are doing in the after developer deploys the application into the stage or production environment. So I'm Mert, I'm security engineer at Amazon. I have a bunch of certificates and I'm generally trying to talk red team, threat intelligence, and application security in conferences, and also we're hiring, and if you're interested in being doing an application security work, you can welcome to apply. So in terms of definition, application security, we can say everything is related to finding, fixing, and preventing security vulnerabilities in the application is called as an application security. And we need to think this definition for all of the application lifecycle one by one. For example, from the developers collecting requirements and creating use cases to creating their architecture to implement that use cases, and throughout the development lifecycle and the implementation wise of this architecture and the maintenance part after the deployment. So at every stage we need to look for the vulnerabilities, and we need to have security controls and measures to find, fix, and prevent them at every stage, not one or two stages. So having this kind of thought makes us make security engineers think end to end and more holistically, rather than focused on just implementation or just deployment parts of the application lifecycle. So having said that, agile practices is also have many variances and also may change by definition wise, but all in all, the agile for me means working in small teams and short iterations, and these iterations having rapid feedback and value-based implementations, which refines requirements as they go. So as a security engineer, we cannot be a conventional one in the agile environment where we're kind of blocking the engineers. Security guys are generally called as blockers, and also moving rather slowly than the developers in terms of the security controls and policies and such. So keeping in mind that agile needs short iterations with small teams maybe requires us to, in order for us to be enablers, maybe we also require to be in small teams at scale. Maybe, for example, for payment developers, for payment teams, there may be payment application security teams if you're working at scale. So keeping in mind that we need to keep up with the agile practice when it comes to application security, because they're moving fast with us, and they're basically prioritizing business, and we need to be the balance factor in the application security, as in terms of application security in the life cycle, in terms of the business and the security. So that's where the being agile comes in. So what can we do about how can we integrate ourselves into these agile cycles and enforce application security controls? So first of all, since the weakest chain in the security is human, it's also valid for application as well. So that's why everything that we are doing in terms of application security, we need to first teach these controls, practices, and such to our developers. Because if you don't, our effort is just going over and over and increase because because developers are going to do the same mistakes again if they don't learn from them. So how can we teach security practices to developers? I mean, we can do meetups, regular meetups for developers. They can be general, open for all developers kind of meetups, or they may be more targeted meetups for some teams. I will come to that at the risk scoring and maturity measurement, but it all comes down to the maturity of the development team. So you can do meetups. You can also teach your developers how to do threat modeling. I mean, one of the things that needs to go in scale and it's hard to scale is the threat model, because many of the application security teams doing the threat modeling themselves most of the time, but teaching your developers how to do that may enhance your development lifecycle for you and the developer as well, because not only developers are going to have security mindset for an extent, they're also going to think about security while they're doing architecture modeling for their application. So they will go hand in hand if you teach developers how to do threat modeling. So to start that, you can have threat modeling sessions with developers. You may model the threats for the developers' applications with the developers by handholding them of how you think, how you come up with that conclusion, or how you come up with that threat, etc., with the reference articles as such, so that developers can learn from them. And also you can maybe have some kind of workshop for developers to learn threat modeling in terms of the onboarding, for example. So the other thing also is the code review. I generally prefer having a code review with the development teams or the individual developers when there's a tricky vulnerability in the static code, so that we and developer can deep dive on that code pieces and define the vulnerability together, so that we can talk about how it happened, how can we prevent it, and in the future how can we learn from them so that we don't do the same mistake in the future. So on that front, code review sessions are very handy for developers, so that they can learn from their mistakes from and security engineers, so that they can have this security perspective on their team or on individual wise themselves as well. So that would enable in the long run for you to having less and less security vulnerabilities in the code, because the developers are learning from them. So, and at the last piece for the security practices, we can have security or application security training to an extent in the onboarding for the developers in the company. I mean, thinking like say that you're a new developer and you're having an application security training on top of your development or introduction to development in X company in your onboarding. That enables the developer to think about security and sees security as not a blocker or boring thing, but one of the things that makes the coding or development more quality, to have more quality in terms of overall perspective. So onboarding having the security application security trainings in onboarding, in that sense, starts every newcomers to think about security in their day-to-day, I believe. So the other thing, once we establish these practices, is the CI/CD part. CI/CD is kind of journey for development. So we can have static and dynamic scans in there, and also container or infrastructure scan in the CI/CD as well for the developers' pipelines, so that we can ensure at least some level of security controls and measures are taken before deployment. And that actually brings us to the risk scoring and maturity measurement. And risk score is what I would like to call based on data criticality and business impact of the development team or the applications that development team is developing, because the risk score is actually for you to understand what kind of measurements or controls that you're going to implement for this team or application, so that you can also measure the maturity of the team in terms of security, so that you can calculate some kind of security posture for the team. So this posture will enable you to maybe have targeted meetups, targeted onboarding trainings for that team only, and you can drive these metrics from the scanners that you have in the CI/CD or scanners that you have for scheduled ones in terms of vulnerability and such, and also maybe from bug bounty and vulnerability reports that I will mention later. And the last piece for proactive approach for me is the abstracting some features for developers. These features, what I would like to call is the not every developer can understand the complex features that well. So as a security engineer, we need to make developers' job or their day-to-day life easier by abstracting these, such as secret management or authentication or authorization logics, because they time to time they may be hard to understand. So a developer, if they understand it not incorrectly or implementing it not completely, may cause headaches for you in terms of security. So abstracting these features is always good in the long run. So a couple of examples of how can we abstract these features is, for example, for the secret management, we can use open source Vault instance, so that we can we can have one place for secrets to store them. And since they are stored in one place, we can have controls and rotations and such as a security team. And development teams can just know the string that they're going to call for this secret in the code and nothing more, so that we can abstract the secret, all of the API tokens, credentials, etc., from the applications and the developers. So developers doesn't have to know about the secrets, and we have total control of the secrets as well, since they are going to be stored in one place. This is just an open source example, but if you're on cloud, you can use the native cloud solutions for that. But if you're hybrid or any other, you're having any other architecture, you can, for example, use these kind of open tools. So the other example for me for authentication and authorization is using the service mesh for Kubernetes platform, for example. This example using open source Istio and SPIFFE. SPIFFE is an identity manager, not identity manager, but identity provider for the services that you have in the Istio. Istio is the service mesh. So your services will have SPIFFE ID to introduce themselves to each other, basically. And Istio supports authentication and authorization policies, for example, and you can develop sidecar for these policies and develop a wrapper, for example, for your development team, so that you can abstract authentication and authorization procedures between the services for the development team, so that they can just have some kind of YAML file for the API or services that they would like to call, or they would like to be called, so that they can you can enforce it on the control plane altogether. And having the service mesh also enables you to enforce MTLS if you prefer. So it's also valid for defense in depth approaches as well. So by implementing this kind of technologies, open source technologies, or this kind of approaches, we can have happy developers, because they will not handle the complex architecture or complex definitions or such themselves, so that we can do them for the developers, and we can have the control like this over the things that we need to control, whether it be secret, authentication, authorization, and segmentation and such. So the also we talked about SAST, DAST, and scanners in the pipeline. So this is also a commit-based sample pipeline with open source tools. For example, with every commit, we can trigger static scanner like semgrep to scan the code that developer wrote. On that front, tools like semgrep is really scalable and configurable for comparing to the some other commercial solutions, for example. So having these kind of scalable tools and configurable tools are must for CI/CD, because we need to be able to configure the ruling in terms of our teams, our needs, so that we can have as much as low as false positive as possible in the pipeline, because having more false positive rate or higher false positive rate would actually make us disablers in the pipeline, because developers would not be able to continue their work that much of an fast pace. So at the so we can look at these as a journey. So for each commit, we are scanning the code, and after that, we'll containerize the application in the pipeline. While we containerize the application, we can scan the container and the third-party libraries that the code has. And after this scanning and making sure that we are having the image and the code that we would like to expect as a security engineer, like the standard-wise. And you can also having some kind of hardening step in the scanning, after the scanning step as well, to check the hardening presence, or you can harden it yourself in the container step. So once you have the container image with the code and the libraries that you expect in terms of the security maturity, you can sign it and push to the registry. So by signing it, you can make sure that this complies your security expectations in terms of security controls. So once we do that, we can deploy this application to the stage environment, where we can trigger some dynamic scanning, for example, using open source tool Nuclei with the templates like rules that we developed for this application, this team, or for our company. So at this stage, our application is deployed to the stage environment and scanned statically, dynamically, and on the container level. And this container is signed, so that it means that it's compliant to our security controls. So after all of these controls and the development finishes, they can deploy the production. So at this stage, the reactive approaches begin, actually, because the application is developed and deployed now. So at this stage, I always prefer having a penetration testing before production deployment, because not every automation can find vulnerabilities as good as security engineers. So having a second eye coupled with the automation and having the human element in somewhere in the deployment is always good to have, and always brings value, in my opinion. So having the penetration testing before deployment is actually beneficial for that matter. So after the deployment, of course, we are going to have CI/CD pipeline there exist, but we can also have vulnerability scanning for the infrastructure that we are having on the production. And also we can time to time trigger a scan for the registry, for example, because not every application has will going to be in the active development. So scanning the libraries and the registries time to time in a scheduled manner is always brings good findings time to time in terms of my experience. So the last piece is actually the having the third eye. I mean, the second eye, the first one would be the automation in the deployment pipeline. The second one would be us security engineers in the penetration testing sense in the deployment for the reactive approaches. But the third eye is actually going to be the bug bounty hunters. I believe that bug bounty is having really good value for its structure for every company. So I would recommend starting with a private bug bounty program in the bug bounty provider of your choice, and moving towards a public bug bounty release as you mature your bug bounty experience. And some of the providers are also providing a managed program, so they're managing the communication with the hackers for you, so you can learn from them in terms of how you can deal with the hackers or how you can triage the vulnerabilities that submitted. So of course, after the triage, you're going as a security engineer, you're going to have the vulnerability with the team yourself and deep dive on it, as I've told you about the code review session, so that you can do, for example, code review with the bug bounty finding with the development team and teach them why it happened and how can you prevent it, so that you can have that knowledge built into the development team for the future. So that's it for my talk. Then again, the main takeaways for me is the having the pipeline and the teaching the developers of outcomes of these vulnerabilities and risks to the developers are essential, because they are going to learn as they mature as well in the security posture wise, so that you can have your effort going elsewhere in terms of the increasing the maturity. So thank you.
So, thank you very much, Mert. Are there any questions from the audience here? Yes, there is one in the back. Just a second.
Hi. Do you have some experience with public bug bounty programs? Can you elaborate a little bit on this? And if not, then on private ones, or how it is organized and yeah, like scheduled in the development lifecycle?
As a bug bounty program manager, I would say you're first having or drafting some vulnerability page for you, as you may see in some platforms. I mean, who we are, what is the scope, what is going to be the vulnerabilities and vulnerability rewards and stuff. So the tricky part is the determining the vulnerability severity scale and the out of scope things, or the things that you want hackers not to touch, for example. So for the private one or the public one, doesn't matter. If you're getting a managed service from the bug bounty providers, they are hand-holding you on that process. But I mean, you can always prepare that yourself by looking at the other successful bug bounty programs on the public scale. So once you do that and you agree with the provider, they're creating a page for you so that you can put these information on there. So on that configuration, or I would say content management page, you're also having integrations, for example, Jira, GitLab, and such. So on the pipeline or the life cycle, you can choose to integrate the bug bounty platform to the issue managers directly, so that every triage vulnerability is going to be ticketed to the respective developers, for example, development team, for example. But the other approach would be the having the vulnerability after triage yourself as a security engineer or security team, so that you can divert or you can filter out the details for developers to understand, for example. So it's you can do it both ways, and it's valid for private and public, both of them.
So, are there more questions from the audience here? No, then I'll check if there were some questions on the stream. Just a second. Okay, so there was a question from the screen. Why do you think this happens? Is setting up CI/CD too complex to include testing suites?
Can you repeat the question?
Why do you think this happens? Is setting up a CI/CD too complex to include testing suites? And there was a follow-up. In my opinion, it seems that a lot of companies don't really use proper CI/CD pipelines.
Yeah, I mean, if you're not having the proper CI/CD structure, you cannot have the controls over there. But it would be like the not having the CI/CD in place would, in effect, having you not shifting left, because you cannot have the per commit scans, for example. But in a sense, what you can do is you have the issue manager and the code repository already in place, and you're also having some kind of stage environment in every other company for application development. So what you can do if you're not having proper CI/CD pipeline set up for developers is that you can have scheduled scans yourself in terms of as a security team for since you have the repository, you can set up some pipeline yourself to scan these like per day or per week or per month basis based on the changes that the repository has. Also, it's valid for the stage environment as well. You can do some differential scans on this on the environment. By differential, I mean on the dynamic perspective, you can have the website saved in configuration wise with some open source tooling or tooling that you're developing, so that you can detect the changes that website has in terms of the code perspective, so that you can just scan the changed part, or maybe you prefer scan it all together for monthly or weekly basis. So if you don't have the proper CI/CD pipeline for developers, you can build one yourself and to initiate these scans in scheduled manner. At least it mimics the pipeline for the developer pipeline.
Okay, then I want to have like a follow-up for that. I think it's quite hard to have like a dynamic analysis in the CI/CD pipeline. Like say if you would integrate Burp into that to automatically scan the application that comes out, it's quite hard to fine-tune it to get the proper results without any false positives. It's almost as complex probably as like the old days you would set up a web application firewall. So you end up with almost double the tasks that you need. Do you think it's beneficial so much to have that all in the place for the cost to the outcome?
Burp, for example, has some headless CLI called Burp Scanner, if I'm not mistaken. So, for example, like if you talk about Burp, once you integrate it into the pipeline, you don't have to use all the findings all together to cut a ticket or having raised an issue, for example. You can always have some sort of middleware to store these and filter these out, so that you can use really actionable findings for the developers. So on that sense, yeah, it's at the beginning it's some kind of time consuming, but in the scale, I would say if you're a small or mid-sized company, it would not be seen as much of worthwhile for the effort, but if going to the scale, it's become more and more beneficial to have it.
Okay, thank you. So, more questions from the audience? No? Then give an applause to Mert. Thank you very much. Okay, we ended a bit short, so we'll continue soon with the next session. Thank you.